So what we're going to be looking here is scatter plot. So and basically from that we can investigate a relationship between two numerical variables. When we do that, we have one of the variables is what we called independent. Previously we've called independent variable, but what we now refer to as explanatory variable, and that is on the x-axis. Okay, and we've also got what's called the dv, which is the response variable. Okay, and that is on the y axis. All right. What we've also so basically what that's talking about is the explanatory explains what's happened. So an example here, you're going to look at the participation rate is going to explain how many hours have been worked. How much fatty food is explaining, so it's explanatory variable, how much weight you put on, just as, as examples of the two types of variables and what they mean. And basically how you can construct it, you put the independent variable stuff, which is this one, onto the x-axis, and you put the dependent variable onto the y-axis, and you'll get a scatter plot like that. And that's basically this sort of shape. X-axis is always that, let's call it EV, explanatory variable. That's always called DV. Oh, not DV. What am I doing? Response variable. Okay. And that's sort of what we've defined here. All right. So I won't go through those examples at the moment. Okay. So here's some instructions on how to actually carry that out. We can see we've put our data in, and once we put our data in, we can go Control I, select data, add data and statistics. Down here, you'll be able to select for whatever your explanatory variable is, and here so that's EV, and that's response variable up there. Okay, and what happens is you end up getting this nice little plot here. Okay, now this can start to work into how do we interpret a scatter plot, and it's important here that we look at these three things. We look at the direction and outliers, if any. We look at the form. So we'll go through each of these in turn. So and the strength. So when we look at a plot, we can see something like that's going to be random, and something like this. Each of these has particular patterns. Like that's got a pattern. That's got a pattern. This has got a pattern. So that's what you're looking at. Okay. So direction is referring to, in terms is it random and there's no pattern, which is like this. There's no pattern. I can't work out where the pattern is. There's no real pattern here. Oops. Okay. And so we can say there's no relationship. Okay. But when we see a pattern like this, what we can see is it's trending in an upwards direction. And that is what we mean by direction. It's trending in an upwards direction, and this one's trending in a downwards direction. And that's what we call negative relationship. So this is going to be, I'm going to write this as shorthand, positive relationship and negative relationship. Oops. Again, I'm just shorthanding that a little bit. So that's a general idea of what we're talking about in terms of the direction. We can look at the form. The form is referring to, is it linear? Because when we're going to be doing this sort of work, we need, if a scatter plot is a linear form, we can say that the variables are linearly related, and we can then do linear regression on our data. So And this is the sort of key point here. So if there's a linear form, so when we're looking at form, we're saying, is it linear? Is there a linear form? So, and we do a bit more of that when we start looking at residuals, all right? But this, as a starting point, we look at the form. Is it clearly linear or is it clearly non-linear? That's what we're looking for. So something like this example here, clearly not linear. Okay, that's the form. We're talking about, is it linear or not? Then we get to the strength. The strength is referring to how, in a sense, this is the proper way to think. The strength of a linear shape is an indication of how closely the points in the scatter plot fit a straight line. So something like this, there's no pattern to it. So it's no linear relationship. And we can represent that by what's called the Pearson correlation coefficient, R. Okay, that's this part here. And we use it at that calculation as a measure of what we, the strength of it. So if I do a perfectly straight line like this, that's got an R of +1 because the plus comes from the fact that it's positive. The negative one comes from it's got a negative slope, but the one is saying, the line's perfectly straight. All right, and here's some examples of 0.7. So if you sort of think a line would go through here, a line would go through, or maybe a little bit up a bit, a line would go through there, and a line would go through sort of there. You can see that this one, as it says here, your data points are close, whereas, not so close anymore. Oops. Sorry about that. Not so close. Did it again. Whereas you look at something like this, there's no pattern at all. So that's why we say there's no linear relationship. And how do we use that? So to use this thing, this is what we're saying. The variables are numeric, the relationship is linear, and there are no outliers in the data. If we have outliers in the data, that can impact on the strength. Okay, so when we've got our, this is a table that's important to realize, because when we're talking about the positive and negative nature of the number, if it's positive in between these two numbers, where we say it's a strong positive, then we say moderate positive between these two numbers, etc, etc, etc. But you notice if it's between 0.24 and negative 0.24, class there's no relationship. And then you start on the negatives again. If it's 0.7, negative 0.75 and negative 0.99, it's what we call a strong negative relationship. Okay. So, and here's just some examples that you can use. These haven't got numbers, but they're talking about whether it's a weak, a moderate, or strong type of relationship. And that's how you can start to look at that sort of interpretation. So if it's asking for something to do with interpret the scatter plot in this context, you're looking at direction, form, and strength. Okay? Thank you.